Better? Yeah, I think that's better. Okay, so we'll be talking about BlackEnergy, which we've been looking at for the past few months. The two main reasons why this malware and these cases caught our attention is because, firstly, it's an interesting example of an old malware family that's been reused for several different purposes throughout its evolution, throughout the lifetime. And also, some of the campaigns detected this year were using the conflict in eastern Ukraine as fuel for its spreading. The Tale of BlackEnergy probably started sometime around 2007. Back then, it was a relatively simple Trojan used for denial of service attacks. And Arbor Networks actually published a white paper on this. Then version 2 saw the light of day sometime in 2010, and it was a complete code rewrite. It became a pretty serious and sophisticated malware with modular architecture being able to expand the functionality. And this time, it was not only being used for DDoSing, but also for bank fraud and spam. Fast forward to the present day, to 2014, and we're still seeing BlackEnergy alive and kicking, and we're seeing it used in targeted attacks. And we're seeing an evolution of the regular BlackEnergy kind, and also something new, which we nicknamed BlackEnergy Lite, but I'll get to that in just a second. Like other complex malware, BlackEnergy consists of several components. Let's take a look at the evolution throughout its lifetime. Let's take a look at the purposes of the driver. In version 2 in 2010, the driver also contained rootkit functionality, so it was hiding stuff on the system, performed some SSDT hooks to accomplish that. Then in the 2014, the regular BlackEnergy versions, they also contain a driver, but it's no longer has rootkit functionality. So the driver's sole purpose appears to be just to inject the main DLL into user LAN processes, more specifically into SVC host exe. And then the Lite variant, which I mentioned, it goes even a step further in not using a driver at all. Instead, it loads the DLL in a, let's say, more polite or standard way simply by loading it through run DLL 32 exe. Such simplification appears to be a trend in malware nowadays, so the trends which were among the highest ranks in malware in terms of sophistication, rootkits, bootkits, rootstock, Olmari, TDL3, 4, Rovniks, and others, are not as common nowadays as they used to be. We can discuss the possible reasons for that later if you want. Obviously, the main purpose of any malware dropper is to drop other components. In BlackEnergy's case, it drops and loads the driver. We're talking about the regular BlackEnergy now. And it does so by enumerating all drivers that are already installed in the system but disabled. It randomly selects one, replaces it with its own malicious driver, and attempts to start it. And it also does a couple of interesting tricks. Now, as you all know, on 64-bit versions of Windows, the drivers need to have valid digital signatures. In order to bypass this security feature, BlackEnergy modifies the system's boot configuration data to allow testing signatures. Now, such modification or such setting should trigger a notification near the system tray, such as this one. And in order to hide that one and stay under the radar, BlackEnergy will patch the user 32 DLL MUI, which is part of the multilingual user interface. So these files, they contain the translations of all sorts of Windows text for all the languages which are installed in Windows. And so what BlackEnergy does, it simply blanks out these texts so they're not visible. Also, another trick, it bypasses or makes sure that the UAC prompt doesn't show up through a shim database, which it carries with itself. So it uses the Microsoft Application Compatibility Toolkit to achieve that. It doesn't do any escalation of privileges, though, so it needs to be running under administrator account. The funny thing is, though, that it elevates, it gets the highest possible privileges that it can get, and shims are the official way of doing that, so they're the official way of achieving this task. Now, at the beginning of this year, we spotted a BlackEnergy modification, which we nicknamed BlackEnergy Lite or Mini. I'll be using those names, both of them, throughout the presentation, mainly due to the absence of kernel mode driver, a lesser support of plugins, and an overall lighter footprint. Now, this was not just a minor version update. The changes, they were very significant. Here you can see, for example, the different format of the build IDs. On the left, a selection of the Lite variants. On the right, a couple of big BlackEnergy versions. Now, is anybody able to spot a trend here? Is anybody able to interpret these version IDs, version numbers for the big BlackEnergy? What they could be? Okay, let me give it away. They're basically timestamps. So D13, these samples were built at the end of last year. Then the other ones are from this year, 2014. There's February, May, June, and the more recent ones from this month. Now, note that both the BlackEnergy Lite variants and big variants are being actively developed, and they're being actively used. And in some cases, we have seen that in attacks, they're being also used in tandem. Also, an interesting difference between BlackEnergy Lite and the regular big BlackEnergy is how it stores its configuration data. The regular BlackEnergy stores it as in the form of XML files, whereas BlackEnergy Lite stores it in an X509 certificate, which is kind of unique, and it uses a crypto API to parse this configuration data. Also, there's a different plugin interface, different means of communication between the plugins and the main DLL. So the plugins, they're not compatible in between the different kinds of BlackEnergy variants. The Lite version communicates through a pipe. And this is the main DLL for BlackEnergy Lite, and you can notice that it only has two export functions, make, cache, and start. In contrast, this is taken from a plugin written for big BlackEnergy, and you can see it's dependent on imports from the main DLL, and it basically loads imports and then calls these functions directly. It doesn't use a pipe. So these are not compatible with one another. Here is actually an interesting case, sort of a hybrid, which we found. And it contains features of both big BlackEnergy and the mini version. It doesn't use a driver. It contains some features which we've attributed to the Lite versions. But it contains the exports, as in the big version. The timestamp is October 2013, so we assume this is the time when the attackers were starting the development of these versions. And actually, we spotted this hybrid after we gave the mini versions this nickname, and apparently the authors also shared this opinion and basically confirmed our finding in that they are also calling it main Lite DLL. Of course, the bare malware would be pretty useless to the attackers, so let's look at the different plugins we encountered while we were tracking it. Most of the plugins in this list are for big BlackEnergy. Now, of course, it wouldn't be a problem at all if the attackers wanted to reuse them to recompile them for the Lite versions if they needed to. Also, the functionality in a number of these plugins overlaps, which is a suggestion that there are many different third parties writing these plugins. So let's take a closer look at some of the more interesting ones. I guess the most important part of every Trojan used for remote access and espionage and data theft is the plugin for or the functionality for stealing files off the victim's drives. BlackEnergy, of course, is no exception. What's interesting is notice this example command. This is actually executed at the start of the plugin. And you can notice what kind of files the attackers are mainly after. So they're after documents and private keys. This is the SI plugin, which is the only one which we found for BlackEnergy Lite during our tracking of the botnets. As the name suggests, it's used to collect all sorts of system information, also some network-related information, And also, it has the capability to collect passwords from various different applications, mostly browsers. The VS plugin is designed to do network discovery. It can enumerate resources connected to the network. It has the capability to get RDP credentials from the Microsoft Credential Store and then attempt to connect to them. Also, inside the plugin is PSExec, which is embedded, and this utility is used to, again, gather system information from the remote computers and is also able to launch executables on them. So this plugin is part of the reason why it's kind of difficult to remove the infection from an infected LAN. Another plugin is used for parasitically infecting executables. Now, since viruses are a marginal thing nowadays, at least in statistical terms, it's always interesting to discover such functionality in malware. So it does its typical viral infection stuff, but what's interesting is that not only does it fix the checksum in the PE header, but in case it's infected a nullsoft installer, it will also fix the CRC32 value. And also, in order to avoid invalidating digital signatures, it simply deletes any. The TV plugin, or the TeamViewer plugin, is connected to this remote control software. It checks if TeamViewer versions 6, 7, or 8 are installed. Version 9, which is the latest one, is not supported in the versions which we've seen. If it's installed, it sets an additional password for remote unattended access, thus creating an additional backdoor into the compromised system. And then there's also a destroy plugin. This is an embedded one, and the command issued to this plugin contains a date and time, and when that's reached, it will act as a self-destruct. So it will rewrite files with these extensions with random data, then it will delete itself, then render the system unbootable by wiping the first 11 sectors of the system drive, and then it will start a driver to rewrite all remaining files with random data. So kind of unpleasant for the people who encounter this. During our monitoring of the botnets this year, we observed over 100 individual victims. Half of them were situated in Ukraine and approximately a half in Poland. Among them was a number of state organizations, various private businesses, as well as targets which we were unable to identify. This is an example of a configuration from an attack at a Ukrainian state institution. What's interesting here that you can see the CNC addresses that the BlackEnergy infection is trying to connect to. And also it supports proxies. So it contained local proxies on the local network, which means that the attackers must have had prior knowledge of the network environment. In April, we discovered a document exploiting the CV 2014-1761 vulnerability in Microsoft Word. Now, this exploit was in the spotlight earlier this year. It was also used in other targeted attacks using other malware families, for example, Miniduke, Sednit, XSH, and others. I won't go into too much detail about how this exploit works, since my colleague Sébastien Duquette will be covering the details on this exploit and also the targeted attacks in which it was used in his AVAR presentation in November. Suffice to say, however, that the successful execution of the payload or of the shellcode drops, obviously, the BlackEnergy dropper and also displays a decoy document to the victim. Now, in this case, the text of the decoy document was quite a controversial one because it talks about Russian ambassadors discussing how they'll take over Catalonia, Venice, Scotland, and Alaska after they've annexed Crimea. Another decoy document, another case, which we found approximately at the same time. The scenario was pretty much the same in this case. The same exploit was used. And the text was a bit less controversial, but still related to foreign relations and diplomacy. The subject was Globsec 2014, the forum held in Bratislava this year. A month later, we found a file called spisok paroli. This time it was an executable, but it had a word icon, which led to many victims falling for this and opening it. And despite being an executable, it also contained an embedded decoy document, which was shown to the victims. And as the name suggests, spisok paroli is Ukrainian for password list. It did contain a list of passwords. This example was also found by our friends at F-Secure, who wrote a blog about it, and who are also releasing a white paper on BlackEnergy. In August 2014, we noticed an interesting case because of the exploit that was used, and also because we were able to see the actual email that was being used to spread the malware. The email contained, again, quite a controversial text. For those of you who, like me, don't speak Ukrainian, I'll give you a rough translation. Arseniy Yatsenyuk, who is the Prime Minister of Ukraine, instructs the Prosecutor General's Office, the Security Service of Ukraine, the Ministry of Internal Affairs, Ministry of Justice, to check all members of parliament, parties, NGOs in Ukraine for the involvement in the support of rebels in east of Ukraine. And then in attachment, there's a list of potential terrorist supporters that should be checked. So what happens when the victim or the potential victim opens the attachment? The text of the PowerPoint slideshow corresponds to the text in the email, and actually it does contain a list of names, I guess alleged probable conspirators, terrorist supporters. But what's more important is what's happening on the background. As you can probably guess, this will eventually lead to the installation of BlackEnergy, Lite. The interesting part is how. The PowerPoint package contains two embedded OLI objects, and both of them contain a remote path as to where the resource is located. So it's a feature of PowerPoint to load these files, and it's a dangerous one. And Microsoft has actually addressed this and updated the object packager DLL, the module responsible for loading these, over 2 years ago in MS-12-005. And users should be receiving warnings, something like these. However, no warning is displayed at all for the PPSX PowerPoint slideshow files. And we tried all of these Office PowerPoint versions, 2007, 2010, 2013, with all the latest patches installed. So combine that lack of warning with the fact that inf, as you all know, is an executable extension. We're building up a pretty dangerous scenario. So what does our inf file do? Can't see it very well here, but the first step is that it will rename the downloaded slide1 GIF file to slide1 GIF exe. Of course, it wasn't an image, it was an executable, and I can tell you that it was the BlackEnergy dropper. And then it launches it simply by setting this registry key, and then Windows takes care of the rest. Now, other infection vectors for BlackEnergy were put to use, not just the graphic ones with decoy documents and stuff. Remember that parasitic infector plugin? So that was also actively used, and we've seen infected installers of Juniper software, which were used to spread BlackEnergy. Also, other infection vectors were Java, TeamViewer, where infections originated from these processes. So there was probably some Java exploitation going on, but we were unable to identify the specific vulnerability that was targeted. And also TeamViewer, perhaps they have used a plugin, such as the TeamViewer plugin that I mentioned, or they got the TeamViewer credentials some other way. And I'm pretty sure there were other infection vectors that we were unable to identify. Also, the Ukrainian CERT knows about this case and a bunch of other similar ones. Now, in this research that I'm talking about right now, we were focusing on BlackEnergy. However, many similar campaigns have been using other malware families out there, such as is described in this UA CERT blog post. So unfortunately, this is just the tip of the iceberg. So coming to the end of my presentation, a couple of interesting facts and Easter eggs. Some of the CNCs used by BlackEnergy were also being used to run Tor relays at some point in time. We also notice an interesting cultural reference. This is a selection of some of the BlackEnergy C2 server addresses. If you take a look at the directories, I hope there's no one in the audience who can interpret this just by looking at it, but I'll help you with dbase, with adding dbase 64 in it. And does this ring a bell for anyone? Yeah, I heard it. Yep, doing references. So the attackers are apparently fans. So to sum it up, BlackEnergy, a malware family first, being used for DDoS attacks, then spam, bank fraud, and now for stealing data and espionage. There were numerous campaigns in 2014 and many more victims. Some of these campaigns have been using CV 2014-1761 for its spreading. And if you're going to Sydney in November, be sure to check out Sebastian Duquette's presentation on this subject. Once we found out that this was pretty serious and what was going on, we took a couple of other additional steps, such as contacting the Ukrainian and Polish certs. We composed an indicator of compromise, and we were in communication with a couple of victims that were also our customers. And we also reported that PowerPoint vulnerability to Microsoft. And the research did leave us with a couple of unanswered questions, such as, why were there so many victims in Poland? Or why were there so many victims overall? Since we know that there were targeted attacks going on, but the number of victims was so large, which begs the question, how many of these were related, how many of them were not, and what portion of them was just unintended collateral damage? And a couple of other questions for you to think about, and that brings me to the end of my talk. Thank you.
Okay, we have lots of time for questions.